Okay, good morning, everyone. Let's continue our discussion of our lessons on the data structure that we can use in R. So we said last time that there are different types of data structures. You have, okay, let me flash that. Okay, a data structure type can be a vector, it can be a list, can be matrices, arrays, factors, data frames. So far, we have we have gone through examples of vectors. When you say vectors, the data is atomic, which means only one type of data. So if it's integer, then everything there should be integer. If it's character, then you cannot include non-character values, non-character data, etc. So we had several examples of a numeric vector. We also learned how to generate random numbers. There are several ways to generate random numbers, different types of random numbers. And we learned how to use the set.seed in order to generate the same, the same random numbers. Okay, so we learned also how to get the attributes of a particular object. Last time we said that everything in R is all about objects. Okay, and let me just sweep everything here first. Everything in R is all about objects, and we can see here what objects we have created and what objects we can make use of. Okay, so then we looked at coercion rules. Now, I think there are some changes already in this coercion rule, but generally, we said that the lowest ranking data type is logical, and the highest ranking type is character. So any of this, whether logical, integer, numeric, complex, can be converted, can be coerced into a character, but not necessarily vice versa. Okay, but there are instances when you can convert a character into a logical value. Okay, but that's not really what we want. What we want to know. Okay, so okay, this one. Did we do this last time? Did you use the sample function?
Parang not yet, sir.
Okay, so yeah, thank you. Now let's this is another type of generating random numbers, and it's actually getting numbers from a certain set of numbers. So let's suppose let's create an object, or let's call it G, and then okay, let me run it here. Let me create a new code chunk. Control Alt I, and I'm creating G. This object G, Alt minus assignment operator, and let's say it's the numbers from 1 up to, okay, 1 up to 500, or 1 up to 1000. Okay, so if you run this, okay, I now have this G, and if you recall, if we're using the column from 1 up to 1000, then this becomes an integer. Okay, the use of the colon here will generate an integer vector. All right, so this time we're going to create a sample out of this 1000 numbers. If we print G, okay, let me print G, Control Enter. Okay, obviously we know that it would be 1 up to 1000. Okay, please don't hesitate to ask a question if you have questions about what I'm doing. Okay, is it clear so far, class? This code 1 up to 100, it will generate a vector of an integer vector from 1 up to 1000. I mean. Okay, may I have your response, class? Kindly chat
Clear
yes.
naman po, sir.
Okay, thank you.
Yes, sir.
Thank you. Good. Salamat ha. Salamat sa sa pag-respond. Okay. Now we're going to use the sample function. Okay. So let's ask the help of R what the sample function is. All right. So question mark sample. Okay. And then it will generate this from the help from the files plots packages window pane. It will generate in the help tab here. Okay. Sample. The sample function is from the base package. So it comes pre-packaged with R, so there's no need to install a package to utilize this function. So it says random samples and permutations. Sample takes a sample of the specified size from elements of X, using either with or without replacement. Okay, so we have here. This is the syntax sample. So take a sample from this object X and tell me what the size is, and then tell me if it's replace. It's either replace equals true or replace is equal to false. What's that? What does that mean? With replacement means it's just like drawing let's say you're drawing a number from a container. Okay, let's say you draw from 1 to 1000, you draw a certain number. Let's say you were able to draw number 99. When you say replace is equal to false, it means you should not return that 99 there to the container. Okay, it means that you cannot draw out 99 again because you did not replace, you did not put it back. When you say replace is equal to true, it means that once you get that 99, okay, you may put it back. So let's say you once again mix the numbers there, and there's a possibility still that you'll be able to get number 99. So that's replace is equal to true. Okay. All right. So this is the basic sample function. Okay, let's now use this to generate a vector of numbers from 1 to 1000. Okay, so let me create now this one, G1, let me call it G1, out minus, and I'm using the sample. Okay, of course, this is drawing out random numbers. So in order for us to have the same numbers, let's set that seed, let's say 99, okay? All right, sample, where will the sample be coming from? From our object G. Okay, which means imagine a container, let's say chips numbered 1 to 1000, and then we're going to draw out some chips from that. So from G, we draw out, let's say, okay, I think there's a question here. Okay, units later na lang ha. Let's say 100. We're going to draw out 100 numbers there. Okay, and then it says here, replace is equal to false. Replace is equal to false means we're not going to return that number that we first drew out. Okay, let's use true. Means when we draw out a number, then we can return that particular number back to the container. So let's just use 50 so that we have a smaller size that it's easily compared. All right, so I'm going to run. I hope you're running it with me. Run this these two lines of codes. Okay, Control Enter, and wait. Let's just put here. Okay, we can put it, remember, in parentheses, or we can just put here print G1. It's the same. Oops, sorry. Print G1. There. All right, I'm going to highlight both of this. No need for this because we have already run this. Control Enter. Okay. All right, so these are the 50 numbers. Kindly chat, please, or just unmute yourself if we have the same if we have the same object called G1. Yes, okay, correct. Good, good. Yeah, we expect our sample to be the same because we used this set.seed. Okay. All right. So what type of data is G1? Let's get the class of G1. Okay. It's integer. Okay. Type of, we know that it's also integer. Okay. It's also integer. Okay. So if I ask you what's the data structure of G1, Russ? What is the data structure of G1? Yeah. Thank you for your answers. Data structure of G1 plus. Anyone? It's a, okay, the data is integer, but the data structure, what do you call the data structure? It's, okay, yeah. The mode, it's, the mode is, yeah, thank you, Francine. Numeric siya for the mode. For the class, it's an integer. For the type of, it's integer. But the data structure, remember the data structure is either a vector, a list, a matrix, an array, a data frame. Okay, so it is a vector. Why do we know it's a vector? We asked for the class of G1 and it says here that it's an integer. So it's an integer vector. So it's a vector, it's atomic in the sense that it only contains one type of data, which is integer. Okay? All right. Clear so far, class? Any questions so far? Clear? Pa-chat naman please kung clear tayo so far. Okay, good. Good. Thank you so much. All right. Now, as I said, a vector is a data structure that contains only one type of data. So it can be numeric, it can be integer, it can be character. Okay. So if you recall, character, did we do this, class? Have we done this last time?
No po, sir.
No. Okay, sige. Kindly write this, kindly follow along. I'll give you time to, as I said, I didn't give you this. I think I don't, did I give you this code chunk? Class?
No, sir.
No, okay, because I purposely want you to write it on your own. Okay, if you take a look at the first line here, we're creating this letter, this object called I, and it's a collection of these characters: Monday, Tuesday, Wednesday, Thursday, Friday. What do you expect will happen when we run this code without running it first, class? What do you expect? What do you think will happen? Anyone? It will generate. Will it
Sir, I
run?
think error po.
Yes, correct. Thank you, Jonas. Thank you. Who was the one who answered? Let me just acknowledge you. Sino yun?
Pinying po.
Pinying. Yeah. Thank you, Pinying. You're correct. Without running this code, class, we know that it will generate an error term because this is not a number. This is not an integer. This is not a complex number. This is a character. However, we know that character strings in R should be placed in quotes. So if I run this, okay, Mon was not found, and so with the others. So if we're going to create this object called I, consisting of these these characters, then we have to put it in quotes. So let me now put it in quotes there. So it automatically prints it because I place it in parentheses. And let's seek the type of I, its character, and the length of I. You know, it's 5. Okay. Okay, so that's very important for us to know that when we're creating a vector of characters, it should be in quotes. The only words that are accepted, words or letters without quotes, is when you're writing through capital TRU, okay, everything capitalized, or capital T, because automatically that will be considered as a logical value, true or false. Okay. All right, so let's move on. Unless there are questions about this. No questions? Okay. All right. Now, how about this? How about this? Okay, so let me once again request you to write this down. You're creating this object called X, and we're combining 1, 5.4, true, and hello. Okay, what do you think will happen? So this is numeric, this is logical, and this is character. Okay, if I run this, Control Enter. Okay, what happened? What do you think happened to the elements of this object X? Anyone, please? You notice something about the print out here of object X?
Character na po lahat.
Yes, correct. Bakit kaya naging character? Di ba numeric, no? Yung 1. Even if I put L here, I'll make this an integer. Okay? If I run this, the same, no? Yeah, naging character sila lahat. Bakit kaya, class? Yeah, thank you, Francine. No? Thank you, Jonas. You're correct. Character is the highest rank among the observations. Yes. Thank you for answering that. And Francine also. It's because of the coercion rule. So we learned last time that when you have a mix of integer, logical, and if you're creating an object out of that, R will coerce those elements into the highest rank. In this case, it's a character variable. Okay, it's a character data. Hello. So everything was coerced into character. And if we run type of X, it's character. Okay, so that's how the coercion rule applies. Okay, any questions? Okay, no questions. Please feel free to unmute yourself or to chat. Okay, I'm not seeing any chat. Okay, all right, let's go now to logical. And this one we already discussed. This cannot be. We're creating this object called J, and it's a word false and true. Now, it cannot be a character vector because it's not in quotes. If I run this, okay, false and true not found. So R is not able to determine whether this is a character or whether it's a logical value. However, when we create this object where we correctly spelled out false and true, capital letters, okay, not small letters. Notice that it's in colored, what color is this? A bit pink, okay. And then let's run this. There. It accepted the object J that we were creating, and then type of, we know that this is logical. Okay, and as I said before, this can be abbreviated into F and T. So let's run this J1. Okay, so this was accepted. And we have this J1 here, J1 object, it's a logical value. Okay, so far, class, I know these are quite simple, and I'm sure you're able to follow along. Unless you have any questions, please feel free to unmute yourself or feel free to chat. Okay, no questions. Okay, I thank you for this chat. Okay, thank you, Martin. Okay, thank you. So no questions so far. Okay, now I think this title is also, I gave this title, right? But the elements here, the codes here, I did not. Okay, this is just a review of what we have discussed so far. So just the more we do it, the more we master the concept. So we're creating this object called numbers. And what type of data will this generate? We have answered this a while ago. It will generate an integer. Because if we're using 1 up to a certain number, the column here will generate an integer. So we can run the whole thing here. Okay. So I have asked R to print everything. So it's 1, 2, 3 up to 10, and then integer and then integer. Okay, I'll let you type this, although this is just a review. And once you're done, kindly chat yes, please, so that I know if everyone has already done this. Okay, thank you. Good. Yeah, thank you. Okay. All right. This one, I don't think I gave you. Okay, what's the difference between the first one, where where we wrote C and then 1 up to 10 in columns, this one, and then this one. So we're creating this object numbers 1. We're combining 1, comma, 2, comma, up to 10. And then we would like to get the class or type of numbers 1, of this object numbers 1. If we run this, okay, you notice that, okay, the class is numeric and the type of is double. So this is numeric. Yes, thank you, Ivan. You're correct. Numeric. As compared to the other one, as compared to the first one here, 1 to 10, this will generate integers. So once again, I'll give you a few seconds to write. Okay. Any questions, class?
Thanks.
Okay, no questions. Good. All right. Next, now that we have identified, okay, numbers, the object numbers is existing. Okay. Numbers is existing. It's an integer from 1 up to 10. So we can generate some operations out of objects that are already recognized by our environment. Okay, so for example, if we run numbers plus 2, what will happen is that it will add to each of the elements of your numbers. Okay, so let's print this also. Okay, so numbers is 1 up to 10. So we're just adding 2 to each one of them. So we have this. Or you can do this numbers times the square root of 10. So what R will do is that it will multiply each of 1 up to 10 by the square root of 10. Enter. There. Okay. So it multiplied 1 by the square root of 10, 2 by the square root of 10, etc. And we can add 2 vectors as long as they have the same size. Okay. All right, let me just go up here. Numbers has 10 elements. Numbers 1 also has 10 elements. So we can add numbers and numbers 1. Okay. So they're both 1 to 10. Okay. So they're just adding 1 plus 1, 2 plus 2, etc. Now what will happen if you have, let's say, let's create a vector numbers 2. And it's a vector of integers from 1 up to, let's say, 6. Okay, so here we have an object numbers 2. Let's just make sure that it's printed. Okay, numbers 2, which is an integer vector from 1 up to 6. Let's run this. So it's 1 up to 6. And then let's add numbers. Okay, numbers plus numbers 2. Okay, what do you think will happen? They have different size. They have different sizes. Numbers is a vector, integer vector of 10, of length of 10, while numbers 2 is also an integer vector of length 6. Okay. Error. Okay. So let's run this. Control Enter. All right. Warning. So there's a warning. Longer object length is not a multiple of the shorter object length. Okay. All right. So what happened was it still added, no? it still added numbers to numbers 2. However, there's a warning that 6, since 6, okay, let's see. So what happened was 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5, 6 plus 6. Okay, and then when it went here, it became 7 plus 1, 8 plus 2, 9 plus 3, 10 plus 4. Okay, so it cycled. So from 1 to 6, it cycled to 1. It will cycle again to 1 up to 6. However, it's telling us that this object, the numbers 2, is not a multiple of the shorter object length. Okay, so let's do this. Another illustration. Let's create another object, numbers 3. At this time, it's let's make it 1 up to 5. 1 up to 5. And then let's add numbers plus numbers 3. Okay, so numbers 3. Something wrong here. Bakit may X dito? Ano ba to? 1, 2, 1, 2. Oh. Baka may space lang kanina. Okay. So this time, let's run both. Okay, here there's no warning. No warning here. Why? Because numbers 3 consists of 5 elements. Numbers consist of 10. So it will just cycle back exactly because 5 is a multiple of 10. Okay, so you can see here 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5. And then this one is 6 plus 1. So numbers will just continue from 1 up to 10. And then numbers 3 will just will cycle back from 1 up to 5 and then back to 1, 1, 1, 5. Okay, so we can add vectors of different lengths, of different sizes. However, there will be a warning if they're not equal in size unless the other one is has a size that's an exact multiple of the other one. Okay. Okay, let me pause for a while. And once you're done doing this, kindly chat yes, please, so that I know if I'll continue. If you have any questions, please feel free to ask. I'm getting 11 responses. You're 26 in class. I hope we reach a certain level where most of you are responding to my queries. Okay, thank you. Yeah, good, good. More responses, please. Okay, thank you. Although I didn't get 100%, next time I hope you get 100%. Okay. Now next, so a while ago we used we have used R norm, we have used sample to generate some random numbers. By the way, I think I forgot to mention to you, where's that? Where's our sample? Okay, this one, G1. Okay, let me print G1 again. Okay, let me print G1 again. Okay, notice, class, that these are 50 randomly selected numbers from 1 up to 1,000. Okay, so randomly selected to. So yung function of sample allows us to pick numbers from a designated set. Okay, unlike the R norm where it's R will choose for us any numbers. If it's R norm, it will depend on the mean and the standard deviation. For the sample function, we have to define what X is. Okay, that's why we created first the G1 object, and then from there, the G object, which is 1 to 1000, and then from there, we ask R to get samples out of that. Okay. All right. So going back here, now let's use the sequence. Okay. So let me run this question mark sequence. All right. So this is coming from base R sequence. It's to generate regular sequences. It's a standard generic with the default method. Okay, sequence.int. Okay, it will generate integers. Okay, and it says here it's more primitive, which can be faster but has a few restrictions. Okay, so let's just use this sequence. Okay, you identify from what to what, by how much. Okay, by how much. Okay, so in a nutshell, that's what the sequence will do. Okay, so for example, this. Let's try to run this. Let's have one example from the sample here and see what what will the sequence function give us. Let me run that in console. So sequence from 0 up to 1, and length that out means how many observations will there be? 11. So if I run this, okay. So you can see now that there are 11 observations here from 0 up to 1, and R will make sure that there are 11 observations. So from this is the first observation, and the 11th observation is 1. Okay. If I redo this up arrow, and then let's say generate, let's say 15 observations. Oh, sorry. Generate 15 observations. Control Enter. Okay. So now, okay, the first number is 0. The last number is 1. And then it divided it into 15 equal parts so that you'll have 15 numbers and that they're equidistant from each other. Okay, how do I know that? Let's see. This one, Control C. Oops, minute. Yeah. Okay. If I get the difference between this one, 0.14 and 0.07, it will be the same as 0.07 and 0. Okay, Control Enter. Okay, it's exactly the same. Also, for this one, Control C, Control B, we're just testing if they're really, okay, I can just perform a negative here just to get the difference between the two. Control Enter. Okay, so you can see here that they're equally spaced. Okay, but that's a sequence. That's what a sequence will do. Okay, it will generate a vector of numbers from a certain number to a certain number and incremented by 0.2. Okay, let's try this. Let's try this, class. So kindly write this. So we're generating a sequence from 1 to 3, and then it should increment by 0.2. So we can define the length that out here. Take a look at this one. You can define the length that out, okay? Or you can define by what? By what should be the increment. So if we run this, okay, so you can see here that it generated a number from 1 up to 3, and that it was incrementing by 0.2. Okay, you can see here the increment is by 0.2. Okay. Also this one, which is similar to what we did here, create a sequence. Notice I didn't put here from anymore because that's understood. From 1 up to 5, and then there should be 4 numbers out of it. Control Enter. Okay, there. 1, 2, 3, 4, 4 numbers, and then the start is 1, and then the end is 5. Okay, so that's what the sequence function does. It can generate numbers from a certain number to a certain number, and it depends on how you want it done. It can be determine what's the length of that sequence, or you can specify what should be the increment of that sequence. Okay. Right. Again, once again, kindly chat, please, if this is clear, if you were able to follow along the sequence function. Okay, good. Thank you. What happened to the other 10 students? Okay, thank you so much. Okay, good. Good, thank you. I hope you're following along, class, and please feel free to ask questions if you have any clarification. Okay. All right, so for this one, okay, suppose we created a vector, let's call it Q, okay, and it will be a sequence of numbers from -3 up to 2. So -3, -2, -1. Of course, we can generate this by the sequence function. Okay, if we want to generate it by the sequence function, it will be from -3 up to 2. Okay, either length that out is 1, 2, 3, 4, 5, 6, or by is equal to 1. It will increment by 1. Okay, so let's create this object Q first. Let me run this. There. By including here Q, it will automatically print our vector. So even if I ask, let's say class of Q, and run that line, so we'll now have this. It prints out Q, and then it tells us that this is numeric. Okay, so if you want to change a particular element in a vector, okay, we can use this. Here we're saying that Q, and then remember this is a subset. We're saying that Q2, which means the second element of Q, should be equal to 0. Okay, so Q subset 2, which means the second element. Okay, here we're not defining the rows and the columns because it's just a vector. It's just one list. So you're not having rows and columns here. A vector will always be one, either arranged as a column or arranged as a row. It doesn't matter. It's just one dimensional. Okay, so let's print Q. And you notice now Q, the second element of Q has been replaced by what we defined it to be at 0. Okay, so once again, I'll let you copy along. And then if you're done, once again, kindly chat yes, please. Okay, good. Thank you so much. Now, what if, because Q is existing, right? It's a vector, it's a numeric vector from -3, 0, -1, 0, 1, 2. Now, what if we let Q be equal to null? What will happen? So we're assigning the word null. It has a meaning. Okay, if I run this, what happened? So Q became null. It means it's empty. And you can see here that in the environment, Q is already null. So it totally removed the elements of Q, which we assigned it to be here. And then when we assign Q to be null, it will overwrite. It overwrote on the value of Q before. Okay, so it's now a null object. Okay, any questions? All right, so let's continue. So we have learned this before. Okay, so maybe just to save on time a bit, since I think you know these things already. So let me put this in the chat box so that you can copy it. Okay, so just copy it first and put it in the code chunk, and then let's discuss. Okay, so here we're creating an object called days, and we're printing it, and it consists of Monday, Tuesday, etc. So let's run this. Okay, so we now have these days. It's a character vector, Monday, Tuesday, up to Friday. We actually have discussed this a bit last time. If I want to get the first element, this is days, and then brackets 1. It means I want to get the first element of the vector days. Okay, it will give us Monday, right? Fourth element will give us Thursday. And we can combine 1, 3, 4. So that would be Monday, Wednesday, Thursday. Okay. And 1 to 4, that would be from Monday to Thursday. Okay. And days -5 means everything except the fifth element. The negative here means you do not include the fifth element. So it will just be the same as Monday. Let me delete this. This is the same as 1 to 4. Okay. All right. So the negative sign there, this means that do not include that element. Why don't we write something here? Days. Okay, brackets. And then let's copy this, Control C, Control V. And let me put here a negative. Okay, negative C134, it means it should not include 134. Therefore, it will only include 2 and 5. So we expect that answer to be Tuesday and Friday. So let's run this, Control Enter. And there you go, Tuesday and Friday. Okay, but let me pause for a while and ask request you to chat, please, if our lessons on vector has been clear so far. So vectors are one of the simplest data structure in R because they're atomic, only one type. And if you attempt to create a vector of several types, it will do coercion. Okay, very good. Thank you so much. Okay, now we move on from vectors to the next type, which is list. Okay. So list. A list, as I mentioned before, is a data structure. Wait. Okay. I'm confused about the time. Kala ko 9:15 tayo, tapos 10:45. Okay, we have plenty of time. All right. A list is an R structure that may contain any other types. Okay. For as long as you define that it should be a list. Remember a while ago, we were attempting to create, let's see, let's create an object out of that. Okay. So here I'm creating this object called list1. Okay. And I'm writing here list. A while ago, we were creating this object, but we placed C, which is concatenate. And it was printed. However, it did not accept the different types of data. It coerced your data. This time I'm going to write here list so that it will accept the different data types. Okay, so we have here numeric. Okay, let's include something here. 2, plus 4i. Okay, let's include a complex number, right? And let's also include, okay, let's include a vector. Okay, let's take a look at this. So this is one data, another data. So these are all numeric. This is character. Okay, this is logical. This is complex. And here we have a vector of integers from 50 to 60. So you have different data types here. And as I said, as we said a while ago, this will only, R will create this object, okay, for as long as it will be coerced into the highest rank data, which is in this case, character. So everything will be coerced as a character. But because I place here list, okay, R will now accept this as it is and create this object called list1. Okay, let's run this. Okay, run. Okay, now take a look at this. So we now have different elements here in your object list1. So here we have the first, okay, let's just show this. Okay, the first here, the first brackets here tells us that this is the first element of your list. And the one here tells us that this is the first element of the first element of your list. Okay, so a number one element in your list, the second element in your list, down up to this is the seventh element in your list. Okay, and in the seventh element of your list, the first element is 50. If we increase this, okay, let's change this a bit. Let's make this 50 to 100. Okay, so let's run this again. Okay, so you notice that the seventh element is actually a vector of integer from 50 to 100. So you have this number 1, which means that this is the first element of the vector in the number 7 in the list. Okay, so this is element 15 in this vector, element 29 in this vector, etc. Okay, so you have here a list which contains, you have numeric, character, logical, complex, and another vector. Okay, so in fact, after you create this, you can create another list. Okay, let's copy this, Control C. And then let me create another one, Control Alt I, Control V, and let me put here list2. And then I'm going to include here, comma, list1. There. Okay, so I'm creating this list. And how many? 1, 2, 3, 1, 2, 3. Okay. So I'm creating a list of the same elements here, including a list. Okay, I included another list here. So let's run this. Okay. So you can now see here. So we created a list, okay, list2, which consists of a numerical, character, etc., just like this one. But I added onto this another list, list1. Okay, so whatever list1 is will be included here. Okay, so you can see here 8. Okay, this is the 8th object in your list, and then you have another layer here, 8 and 1, 8 and 2, because this is defining now this list 8. Okay, I hope you're not confused. Okay, so which means, class, that you can, in creating an object called list, you can include vectors and you can include other lists. Okay, as I mentioned here. Okay. Okay, this one we cannot do because did we create this object my vector? I don't think. Let me run this. This will contain an error term because my vector is not included. Maybe let's just use. Let's find a number here. Okay, let's choose days. Let's replace this with days. Okay. No, sorry, because its list can contain lists and vectors. So, okay, actually we can include list too. Okay, now we have, this becomes a little bit more complex because we're creating an, let's name this object list 3. So we now have this object list 3, and it contains a list of list 2. List 2 is a list which consists of another list. Okay, so this becomes quite a bit complicated. It's okay. Let's print list 3. All right. So, ang dami ng layers, no? Ang dami ng layers kasi yung list natin consists now of list 2, and list 2 consists of a list with another list. Diba? And it can go on and on. So okay lang yun. But we're not really interested in that so much. What we just want to know is that list can contain different types of objects, unlike the vector, which is atomic. The list can contain vectors. It can contain also other lists. Okay. In fact, it can contain also. It can contain also a function. Okay. Here we're creating this object called myList. Okay. Let me pause for a while. Maybe your nobody's asking me if to stop for a while, but let me stop for a while just to let you write your code. Okay, if you're done, class, kindly chat, please. So let's wait for the others to complete their codes. About the rest, Josh? Please feel free to ask your questions. You may unmute yourself or raise your hand. Let me check. Okay. All right. Mukhang wala namang questions. Okay, good. Thank you so much for your responses. All right. So, as I said, you can include a function in list. Okay, here we have C is equal to a function of X, where and X, C is defined by multiplying X and sin X. Okay, let me ask you to copy that first. Excuse lang, class. Let me just pause recording. Please remind me to continue recording. I'll just answer somebody at the door. Okay, as I said, a list can also contain a function. Okay, here we have function x. And then you can run this so that if you replace, for example, x with a certain number, then it will perform this x times sine of x. So let's run this. Right. So here you have, this is a vector of integers. You have here, you have a character, and then you have here a function. Okay, we'll learn more about functions as we go on. All right. Okay, so what happens? Okay, so we have this object my list. Let's get the type of my list. And you see here it's a list. It does not say integer or numeric character. And we know it's a it's a list. Okay. If you go here, class, we have done several lists already a while ago. We have list 1, list 2, list 3, my list. Okay, if we click this, for example, if I search this, list 1, click this, it will generate this window, okay, and it will print actually what's inside our list. So list 1 consists of 7 elements. The length is 7, and then it will tell us the type of the object there. For example, 1 is a double, 1, 2, 3, they're numbers, right? The fourth element of our list is character, that's hello. The fifth element is logical, it's false. The sixth element is complex, okay? And the seventh element is a vector of complex of integers. It's an integer vector. So that's what we can find in list 1. Okay, and if we check list 2, this is the list with another list. Okay, there. You notice here that list 2 consists of the same element as list 1, but it has an added 8th element, okay, which is a list. Okay, this is what I'm saying. So a list can contain also another list. And this list contains 7. If we click this, it will now generate what that other list is there. Okay? All right, so let's go back to okay, let's skip that. We already discussed our norm. Okay. All right. So unless you have any questions about this one, okay. Okay, well, why don't we quickly do this? No? Set that seed to 50, and then we're creating this object called A using our norm, just 10 elements. Okay, what's the mean of this? What's the mean of A? What will be the mean and the standard deviation of object A? We're going to run this class. Anyone, please? Do you recall, class, the R norm that we learned last time? It will generate 10 random numbers, normally distributed, with a mean equal to, what will be the mean?
0, sir. The standard
Correct.
deviation of 1.
Yes, thank you. Thank you. That's perfect. That's correct. So let's just run the second one, okay, because there are some functions here that we can do. So set that seed 2, 3, 4, and then let's generate, maybe let's just generate 100. Okay, 100 random numbers with mean 450 and standard deviation is equal to 10. Okay, so let's run this too. Okay, actually we can run everything here. Okay, let's run everything. Okay, there. Okay, let's just replace let's not print this and just replace by head. Naglobat na yung ano ko, yung my values, head lang. Okay, let's run everything now. Okay, so everything is, why did it still print? Bakit pa rin niya print yung ano? Okay, sige. Ito na lang muna. So these are the first 10 elements. We should have the same answers. Do you have the same answers, class? Same answers? Okay, thank you. All right, then this is just a review actually. We can compute for the mean, the median, the minimum, maximum, the sum, standard deviation. This one can print the answers here. We should have the same values for the mean, the standard deviation, the median, etc. Okay, I'm going through this very quickly, class, because we have done this before. And then the class, we know that this is numeric here. Okay, I'll just look at this one on the side. It's numeric. And then the length, it's 100. And then we can generate the log of my values. So it will get the log of each of the values of our data set, my values. And take note that when you use log in R, the base is always E. Log 10, on the other hand, will give us the base 10. So there's a difference between log and log 10. Okay. If I press here head, just the first 3 values. Okay, 1, 2, and then this one head 3, also 3 values. So let's run this both. All right, you can see here that the log and the log 10 are different in in answers. Okay, if you use log in R, for log, the base is E. Base E. Who knows what the value of E is? Anyone?
Estimated at 2.718 tatas.
Yes, correct. No? And how do we get that? Let's get the value of E. E to the first power, there, 2.718282. Okay, so that's E. So the first one here, if we're going to use log, it's using the base E. In order for you to use log base 10, you have to write log 10. Okay, so we will be needing this this information once we go to multiple linear regression, where we need to get the log of some variables. Okay, and then here's my square root. You can do that also. And then here, histogram. Okay. Histogram of my values. There are some outliers here. Not so. Okay. It's not so much, although we use the R norm, but because of the small sample size, it doesn't really give us a really normal distribution. And the plot, okay, the plot gives us the scatter plot. Okay, it plots the number, the index from 1 up to 100 on the x-axis, and my values on the y-axis. And then it can also give us the box plot. Okay, box plot here. As you can see here, there seems to be an outlier here. This one. Okay, if you recall, this is your box plot. This is your median, first quartile, third quartile, and this is your upper whisker. This is 1.5 times IQR, 1.5 times IQR. And this outlier in this one can be seen in our histogram here. Okay, if you can see this one, okay, there's this presence of this outlier. Okay, clear so far, class? Any questions? I hope I'm not going too fast. Let's wait for the others' comments. We did this before already, I think, if I'm not mistaken. That's why I'm going through this, because it's just a review for us. Of course, class, you cannot get, for example, just to mean of least one. Okay, you cannot do this. Okay, because a list is supposed to be a collection of different types of objects. Here we were able to get the mean of my values because my values is a numerical value. Okay, I hope that's clear. All right, then we go here. All right, we have an introduction to data frames. Okay, data frames are one of the most important objects that we're going to learn in R. Okay, let's first see what are the what a data frame is. Okay, a data frame is a table or it's a two-dimensional array-like structure. Every column contains a value of one variable. Okay, so if you recall the diamonds data set that we did we do that, class? Did we generate the diamonds data set? Can you chat, please? Oh, di ba yung diamonds data set, no? In diamonds data set, that's an example of a. Why don't we do that? Library muna natin. We know we need to get ggplot2. Okay. And then data. There, diamonds. No? Control enter. And then we can view this, view diamonds. All right. So this is a data frame. Excuse ulit class. Okay, so this is an example of a data frame. Okay, it's a rectangular like. Okay, so you have here columns have names. Ito yung mga variable names natin, and each row is an observation. This is a data frame. In fact, I think we did this class ng diamonds. Control enter. Okay, so it's a data frame. A table data frame, table, they're the same thing. A table is just a special type of data frame. Okay, so let's go here. So what are the requirements for a data frame? First, the column name should be non-empty. The column should have a name. Hindi pwedeng walang pangalan. The row name should be unique. Each observation should be, each row should be a unique observation. Okay? When you say unique, dapat this is one response. This is one respondent. Okay? Pwede naman na, for example, you're surveying students, pwede naman pare-pareho yung ano, depende sa variables. Pwede siguro kung age to, kung frosh, kung residence, etc. It means that it can be the same. However, it should not be the same person. Okay, so that's what we mean by the row name should be unique. Then the data can be numeric, factor, character. So pwedeng numeric siya, pwedeng integer, pwedeng factor, pwedeng character. And each column should contain the same number of data items. What do we mean by this? Bawat column should be same number of data items. Which, let's say, kung karat, kung 53,940 yung rows ng karat, dapat ganun din yung sa color, yung same for clarity, same for all. Hindi pa pwedeng si clarity 100 lang yung laman. While si karat 53,940. Okay, dapat pare-pareho sila. Okay, so each column should contain the same number of data items. Okay, I think I included this. Okay, do you have this code also? Kindly chat please if you have this code. Hello? Do you have this code, class? Wala. Okay, let me just copy that so that we nagba-battery low na ako. Buti na matatapos sa tayo. Control C. Okay, so let me share with you the code. Kindly copy it. All right, here we're creating this object N, and N contains 3 elements, 3, 4, 5. It's a vector of numeric. S is a vector of characters. B is a vector of logical values. Okay, and we're creating this object called DF. Okay, DF is we're going to coerce it or make it as a data frame. So the function is data.frame, and it should contain N, S, and B. So let's run this first. Let's run the first 3. Control Enter. So it ran 2, 3, 5, and then these characters, and then the logical values. And let's create this object. Okay, by the way, to take a look at our vectors, they're here. NSB, no? N, and then you have your S, and then you have your B. There's your V. The values are your vectors. Okay, and then let's create this object called DF, and it's a data frame consisting of your NSB. Let's run this. Okay. If you take a look at our object here, sa data natin kasama si DF. Okay? And yung variable name niya N, yung first column, yung S, second column, and your B is the third column. And then it tells us your N is double, numeric siya, S is character, and B is logical. Okay, pause muna ako, class. Were you able to follow this one? Paki-chat naman please kung yes. Okay, good. All right, thank you so much. Now, if you recall, we can get the structure. Let's get the structure of let me close this. Let's get the structure, str of df. Okay, let's run this. All right, as you can see, df is a data frame. 3 observations of 3 variables. And this one, remember we use this $n, which means n is part of your df object. Numerical 235, $s, character AABBCC, and $b, your logical. Okay, we can also get the summary. We did this before, summary ng df, and it depends on the type of data. Okay, if it's numerical, then it will give us the number summaries. If it's character, and it will just give us the the length. Okay, three characters, and then if it's logical, it will give us a count of the false and the true. Okay. All right. Okay, so let me stop there because this is a long example. So next meeting, we're going to continue with this. We're going to take a look at other data frames. This, how to create data frames, which we already started doing. And then we will learn how to create more data frames, give names to change the variable names, etc. So this will be our lesson for next meeting. Okay, and then we go to date objects, very important in finance. We're going to learn how to use the Lubridate package. Then we're going to do matrices. Okay, matrix. We'll do some matrix algebra, learn some operations of matrices, and then we will look at. Okay, these are all matrices. Okay, so I think that's about it. And then we have here some questions. Okay, so hopefully, maybe we'll not be able, or maybe maybe what we can do is I'm going to post a video about this so that you can start viewing it, so that we'll be able to move on to the most important lesson, because this is just introduction to R. This is not really the main lesson of, this is not FinStud, this is FINTSAR. This is more of multiple regression analysis, and time series. It just so happened that we need R as a tool for our analysis. That's why we're spending some time. So maybe I'll just post a video about maybe about matrices, and I would like to request you to view it so that when we meet next time, it will be more. We will have more of the discussion rather than the coding itself. Okay, so let me stop recording.